Okay, so all these word problems they're going to have just tell you to solve. So that's going to be our generic directions is going to be to solve. And then what we're going to do is copy down the first word problem that's on that worksheet. And the types of problems you're going to see on your homework are most reminiscent of this problem and the last problem that we'll cover. So it says the sum of two numbers is 5. The larger number exceeds twice the smaller by 14. Find the numbers. So you're going to recognize these problems as problems we've done in the past. But in the past, we could only use one variable. So this is going to be a new way to solve these problems. Okay, so what are the things that we're solving for? Anybody? Two different numbers. So we're going to use two different variables. We'll use x, and we'll say a number, and y is a number. Now, did they describe these numbers in a different way? Did they just call them numbers, or did they describe them differently in the problem? Lily?
One is bigger than the other.
Okay. So they called one a larger and they called one a smaller. So what I'm going to do is add that to my definition so that when I'm translating, I know who's x and who's y. So which one do you guys want to be the larger number, the x or the y? Okay. You guys are the same as everybody all day long. Oops, you just said larger and I wrote smaller. There's my brain. Okay, so larger and smaller are two numbers, okay? So now we're going to get into the translation. And how it's going to work is typically word problems are in, a lot of times 3 good sentences. Sometimes I have a lot of filler background that really doesn't help me solve the problem. It just kind of gives me some insight into the problem. But this one we've got the stereotypical 3 sentences. The first 2 sentences are going to be the sentences we translate. The last one tells us what we're solving for. Okay, so we usually have a question or a statement of what you're supposed to be finding. So how would I write in math the sum of two numbers is 5 if the two numbers are defined as x and y? Okay, Jordan C?
X plus y equals 5.
Yeah, the sum of two numbers is 5. Isn't that so much easier than what we had to do before, where one was, see, one number is x, the other is 5 minus x, because we had a sum. One is x, one is total minus x. Now we don't have to worry about that anymore, because we can use the two variables. But the number of variables requires the same number of equations. So I've got 2 variables, I need 2 equations. So I look at the next sentence. The larger number, who did we say was the larger number? So x exceeds twice the smaller number by 14. How do I translate that portion of it? Because I didn't hear any is or anything like that. John?
X equals 2y plus 14.
Very good. Because exceeds actually played 2 roles in this problem, right? Exceeds told me more than. It's greater than. And it also played the role of the difference between here's equals on, or the x on one side, and here's everything else on the other. All right, so looking at our system, which of our strategies would be best to use in this particular problem? What's it set up for? Anybody?
Substitution.
Totally set up for substitution. So what I'm going to do is take the expression that represents x and substitute it into the equation for x. So now I have 2y plus 14 plus y equals 5. Somebody's phone needs to get turned off because that's not mine. So I'm going to go ahead and do opposite operations to get the constants together, and then I have some like terms to combine. So that gives me 3y equals negative 9. Now I'm going to continue my problem over here. And we have 3y equals negative 9. Divide both sides by negative 3. No, sorry, positive 3. And we get y equals negative 3. Now I'm going to substitute that value back into either original equation. It really doesn't matter which one. I think this one's pretty easy. And I'm going to solve for x. So I have x plus negative 3, which would be x minus 3 equals 5. Add 3 to both sides, and we get x equals 8. Now remember, I don't write this in ordered pair, but I still am going to check because I want to make sure that I'm not making any dopey mistakes. So, does 8 plus negative 3 actually equal 5? Yes, it does. So that's a good answer. Does 8 actually equal 2 times negative 3 plus 14? So 2 times negative 3 is negative 6 plus 14. I get 8 equals 8. So what I've just proved is the two numbers are good. So how do I write my answer? Again, it's not an ordered pair. So we just list the two numbers. We say 8 and negative 3. The order of the two numbers, doesn't matter. I could say it's negative 3 and 8. I'm not going to use a comma because then my brain's going to want to put parentheses in, and I can't do that in these. Okay? All right, the next two problems are somewhat related, and we're actually going to spend a day talking about strategies and solving them. These deal with something that you should be very familiar with and should not be a challenge for you to write down now. Again, the questions you're going to work on homework are going to be most like the one we just did. So second problem is going to be the second one on your sheet there, and it's about the bank teller. So we have a bank teller has a 112 $5 bills and $10 bills for a total of $720. You need to not play on that computer, please.
Oh no, I just bumped it on my elbow.
Okay. How many of each bill does she have? Now, this one only has two sentences, but packed in one sentence, they talk about a lot of different things. Okay, first off, what are we solving for? How many $5 bills and how many $10 bills? So we've just figured out what our X and Y are. X is going to be the number of $5 bills. Oops. And Y is going to be the number of $10 bills. And I tend to just write my variables in terms of the order that information's given. All right, so two unknowns means I have to write two equations. Now, what two different types of information do they tell us about those $5 bills and $10 bills in the problem? What's one, Mikey?
The total of the bills.
What do you mean?
The total of the physical bills that she has.
So how many bills physically she has? And that number was?
112.
112. And what's the other thing that they tell us about the bills? Emma?
The money value.
How much those total bills, those actual physical bills, add up to equal. Okay, so we're going to do one equation that deals with just the number of bills, and we're going to do one equation that deals with the value of the bills. So how would I write an equation that describes how many $5 and $10 bills there are in this particular situation? Who's that? Michael.
X plus Y equals 12.
The number of $5 bills plus the number of $10 bills is 112 bills. Okay, so X plus Y equals 12. Now, how would I write the equation that deals with value of the bills? Amanda C.
You would do 5x plus 10y equals 720.
Very good. One $5 bill is worth $5. X amount of $5 bills are 5x. Okay, and so the value of our bills are going to add up to equal 720. All right, so looking at this system, what would be a strategy that you would use? Yeah, we're going to be able to add these together in order to eliminate one of the values. Is this best case, second best case, worst case scenario? Yeah, this is kind of worst case. But it's not the worst, is it? Because all I need is to get a match. And you notice the top equation, coefficients for x and y are 1. So this is actually pretty cool. So somebody share with me what I should multiply that top equation, x plus y equals 112 by in order to force a match to occur. Blake, yes? Okay. So by multiplying by -5, what is Blake going to match? He's going to match the x's. So he gets -5x minus 5y. And I like the fact that he, without even hesitation, said, you got to make it negative. Because otherwise this will have same signs and that won't work. And let's see, we get a 10, 5 and 1 is 6, so we get -560. Now the other equation we haven't touched, so he'll come back down again. 5x plus 10y equals 720. So now we're ready to add the two equations. And when we add, we eliminate the 5x's. And we're left with 5y equals... And by the way, what kind of answers, when you if you got them, you go, wait a second, I have definitely done something wrong on this? What kind of answers would not make sense in these? Blakeham?
Decimals or fractions.
Yeah, if we get decimals or fractions, that's saying we're talking about a part of a bill. Like somebody ripped a bill in a piece and said, here you go, here's 2/5 of a $5 bill, which means it's worth nothing. Okay, what other answers would not make sense in this problem? Blakeham? Or Blakeham, sorry.
Negative answer?
Yeah, we can't have negative bills. That's the absence of bills. Okay, that might be the reality of your piggy banks, but not going to be for our word problems here. 5 goes into 16 3 times, which is 15 with 1 left over, and 5 goes into 10 twice. So right now, we think that there are 32 $10 bills. So let's figure out how many $5 bills. So we have x plus 32 equals 112. Subtract 32 from both sides, and we get x equals 80. So at this point, this is what we think our answer is. We have 80 $5 bill. Oh, hello. I'm writing like you guys. $5 bills. Even though we say it at the end, it comes in the front. And we have 32 $10 bills. Now, before I go ahead and say, yep, I know that's the answer, I only have one place I need to check. I got 80 from doing x plus y equals 112. So where I want to check is the 5x plus 10y equals 720 and see if that works. So let's do that check. And let's see, we get, is 5 times 80 plus 10 times 32 equal to 720? Well, 5 times 80 is 400. And 10 times 32 is 320. 400 plus 320 is 720. So that means I've done the math right, and that says those would have to be the correct answers. So even though we haven't talked about coin and value problems really this year that much, you guys should know this based on past experiences. I'm going to teach you a strategy when we get into that particular word problem to help keep things organized. All right, let's do another one similar. But instead of bills, we're going to talk about tickets. So this is the third one. Tickets for a school play. Cost $4 for adults. And $2 for students. $600 tickets were sold worth $1,900. How many of each type of ticket were sold. Okay, so what are we solving for in this problem? Sure.
How many kinds of how many adult tickets were sold and how many student tickets were sold?
So how many adult tickets were sold and how many student tickets were sold? So I'm going to go and veer from my typical X and Y, and I'm going to change my variables to match this problem. So I'm going to let A equal the number of adult tickets and S equal the number of student tickets. And just like in the last problem, they talk about the tickets in two ways. What are the two ways that they talk about the tickets? John? Yeah, they talk about how many were sold and how much it was worth. So let's write an equation for how many were sold. Okay. Kate, what would be the equation for how many were sold?
A plus S equals 600.
Very good. And Megan, what would be the equation for how much money they made?
A plus S equals 1900.
No, because that would be one adult ticket plus one student ticket equals $1,900. That's one expensive play. Okay, so remember back when we were doing $5 bills and $10 bills and we wrote the equation about the value of them? How did we write that?
Oh, it would be 4A plus 2A.
Yeah, we need to put the value of 1 times how many there are. So 4A for the adults, the value of 1 times how many there are, 2S, and that equals the 1900. All right, what's our strategy we're going to use on this? Elimination? Okay, and it again is a worst case scenario because we don't have any matches. But the nice thing is it's a okay worst case scenario because I actually only need to multiply one equation by something in order to get a match. What could I multiply the first equation by in order to get a match? What do you think would be a good one, Nicole? -4? Okay. So I like how Nicole realized I got to change signs. So she gets -4A minus 4S equals -2400. And then the other equation didn't get touched. 4A plus 2S equals 1900. So we're going to go ahead and add these two equations together. It eliminates the A's, and let's see, we get -2S equals -500. Divide by -2, and we get S equals 250. So I'm pretty glad that that switched. I was getting a little nervous there. All right, let's figure out how many adult tickets. Easiest place is to go here. And we have the number of adult tickets plus the number of student tickets, 250 equals 600 tickets. Subtract 250 from both sides. And we get 350 adult tickets. So right now, looks like my answer would be 350 adult tickets, 250 student tickets. So we are going to check that answer. Amanda S., I guess you're going. And all I need to check is I don't need to check that A plus S equals 600 because that's where I got the 350 from. I'm going to check here. So 4 times 350 plus 2 times the student tickets of 250. The question is, does that equal the 1900? and I'm cramming myself over here. So let's see what we get here. We get a 0, we get a 20, 12 and 2 is 14, so we get 1400 plus 500. And 1400 and 500 is 1900. See ya. And it matches, which says that answer looks pretty good. Okay? All right, we got one more. And this last one should be a little familiar to you. It's the number 4 on that sheet. And it talks about our old friend, Mr. Rectangle. The perimeter of a rectangle is 48 centimeters. Its length is 4 centimeters less than 3 times its width. Find the dimensions. So what are they asking me to solve for in this problem? Yeah, length and width. So I, again, am going to alter x and y, and I'm going to let L equals length. I know this is shocking. And W equals width. Question 1, or equation 1, comes straight from your memorization, which I've told you from the beginning of the year that you need to know formulas of certain things. What would I write for the translation of the perimeter of a rectangle is 48 centimeters? Ethan L.
2 length plus 2 width equals perimeter.
And perimeter is what?
48.
So remember, we can only have 2 variables. Don't give me a third one, because then I'm going to have to write 3 equations, and we're not ready for that yet. So 2 lengths plus 2 widths equals 48. How do I translate its length is 4 centimeters less than 3 times its width? How do I translate that one? I'm going to call on Kaylee. Kaylee, translate the second equation.
L equals 3W minus 4.
Wow, that took you no time. Very good. 4 less than is a switcher phrase. 3 times the width is 3W. So we get length equals 3W minus 4. So which of our strategies is this one set up for? Substitution. So this is why I write this down, is so that you guys start paying attention to what did they give me and what strategy would work out best. What's going to require the least amount of work. So here's the part you have to remember. There's a 2 in front of that L. So it's going to be 2 times the quantity 3W minus 4 plus 2W equals 48. So distributing, we get 6W minus 8 plus 2W equals 48. I'm going to add 8 to both sides to get the constants on the right, and I'm going to combine up like terms. So I get 8W equals 56, and when I divide both sides by 8, I get, I went back to X. There's my brain. I get W equals 7. To figure out what the length equals, I'm going to plug into this formula. So I get L equals 3 times the W, which is 7, minus 4. So I get L equals 21 minus 4, and I get L equals 17. So right now, this is exactly how I would write my answers. I identify which answer is which. Length is 17, and I add a measurement label, centimeters. Ethan L., this is not an observation class. You need to actually be writing. Okay, you need to write what I'm doing, because if you aren't going to show your work properly, you're going to get points taken off. That's why I need you to make sure that you're not skipping corners that I'm going to be looking for. Now, I'm not going to plug my numbers back into the L equals 3W minus 4, because I just did that to get the L value. So where I'm going to plug my numbers into is the top equation. And see if 2 times 17 plus 2 times 7 actually equals 48. So I get 34 plus 14. And I sure do get 48 equals 48. So what that says is feel confident that those would be your 2 answers. So again, the homework you have for tonight is going to be more like the first example and the fourth example. We're going to have a whole night of homework on the second and third examples. Okay?